Good morning and good afternoon, everyone. We're depending on where you are in the United States. Thank you for joining this coffee break seminar. My name is Holden Gibler. I'm an applications engineer for data physics. Today we'll be discussing channel math in SignalCalc 900. So for the agenda for today, we'll go over what are math channels, how to set up math channels, and also some practical applications. I have my own shaker system, and I'll be able to take live measurements once we set up the math channels. Brief overview of math channels. So math channels add the ability to create virtual channels. Math channels can use basic math operations such as adding, subtracting, dividing, multiplying, integrating. They're computed real time, so displacements remain accurate. Math channels can operate on other math channels, which I'll demo for you all. Math channels can be used in a vibration control test or a signal analyzer test. And they're created just like input channels that can be used as a control or limiting channels in a vibration control test. So here we have our managed test screen. Hopefully you all are familiar with this. If I wanted to start a new test, I would go to test new and start a new measurement. But in this case, I already have a template made to save time. This will be here. So I want to access that template. So I'll right click on it and edit test setup. So here I have my channels tab. So hopefully you're all familiar with the inputs and outputs. So in this case, I have a accelerometer in the center of my test structure. So what I have, and for context, I have a beam on a smaller shaker. I have a control accelerometer, or a central accelerometer on the center of the beam, and then I have another accelerometer on the far right of my beam, and that's input channel 2. And then I'm output a random waveform to my shaker. So that's the inputs and output setup. If I want to access math channels, I'll click math here. This is our math channels window. I can click add here in simple operator. So here's where you would name a math channel. It'll show the equation of the specific operator, and this is where you select the operator. So as you can see, we have a lot of operators here. A simple one would be just adding a scalar value to a channel. So it's a plus stream, and the a value is a scalar. So I can change this to whatever value I'd like, and it'll almost offset that data from that input channel. But in this case, we want to do some actual measurements here. So we're going to take the averaging of the two channels. So I'll find this measurement, which takes stream 1, stream 2 in a series over the number of operands. So in this case, I'll call it channel averaging. And I will average my two input channels together. Right now, as you can see, it's input channel 1, input channel 1. It'll just average 2 copies of the same input channel. I want to change that, so I'll select input channel 2 here. So now it'll average the time data between input channel 1 and input channel 2. I'll click validate, and then I'll click OK. And this will be displayed. And as you can see, this updates into our input channel. So they're treated just like input channels. And what will make more sense in a moment. I can also add filters this way. So I'll go to simple operator. When I say add a bandpass filter, I can go to operands. I can go all the way down to the bottom, and we have a low pass filter option, high pass, bandpass filter. So I'll add a bandpass filter, and you can change your cutoff frequency to whatever you need. In this case, I'll do like 10 to 300 hertz, and I'll filter input channel 1, and I'll click validate, click OK, and this adds my bandpass filter. If I want to add for example, a triaxial resultant. In my case, I only have 2 accels on the same axis, so it's not actually a triaxial resultant, but it is a resultant. So I can go down to my resultant, and I can name it triaxial resultant. And I can again select channel 2 here, so now it'll take the resultant of these 2 channels. I'll click validate, click OK. That'll give me the triaxial resultant. And then if I want to go to, for example, I want to find the displacement of each of my cells. So I can go to add a simple operator, find my double integral channel. It'll be here. I can name this displacement center. And I want to find the displacement of my center accel. So it'll be input channel 1. If I wanted to find the displacement of my right beam accel, I'd use input channel 2 here. But in this case, I want to find the center one, so I'll do the center. I'll click validate, I'll click OK. And then I want to find the displacement of my right accel as well. So I'll call it displacement right. Find my double integral channel again. go. And I'll select input channel 2. Validate. Okay. And now what we can do too is I can actually, I can find the relative displacement and I can do map channels with other map channels. So what I'll do here is I'll hit add, simple operator. I'll just do a basic subtraction operation and call it relative displacement. And I can, instead of doing these input channels here, I can actually select map. So I go map, and that way I can actually perform map operations with other map channels. In this case, I want to find the channel number. So in this case, my displacement center, as you can see here, the channel number would be 4. So I'll select 4. And then I want to take the relative from the right Excel as well. So I'll select channel 5 for this Excel. I will hit, and it's going to be in inches because it's a double integral. So I will validate. Okay. So there's my relative displacement. We can also add a kinematic transform or kinematic matrix. So here, this is useful for a 6th degree of freedom system, and you can put different sensor locations all over the channel table and define a local coordinate system. In this case, I'll just do a basic local coordinate system here of just center of the armature. I'm going to change since I only have 2 Excels and 1 axis, I can just find the translation in the z-axis, which I'll define as up. So I'll enable these 2 channels here. My center accelerometer is a little bit offset from my center, so it's a little bit to the right. So I will put 1, and then my right accelerometer is all the way at the end of my beam, so I'll put 3, and then the direction of translation will be in the z direction. If I go to, then I can go to preview here, and it's just the coordinate transform, the different units. I'll hit accept, and it'll add this kinematic transform as a map channel. I'll have to enable it though, so I'll go down here and with the check marks. All right, everything looks good here. So what we'll do now is we'll actually take a measurement. So I'll hit save. And now we are in our table. I'll just launch it again. So you double click here, reopen. Just that's how you would launch a test. Here I have my time data, my spectrum, and frequency domain. I want to launch my test, so I will hit initialize, hit continue, start, and now I will start seeing data. So here I have the time data from my center beam Excel, and then X2 is my input channel on my right accelerometer on my beam. Now I wanted to be able to display the map channel. So what I'll do here is I'll add a new graph. I will click add signals, click multiple graphs here. So now, as you can see, there's a lot of different options I have. And from here, X7 all the way down are all the different map channels. So I have my channel averaging that I'll add. I have my bandpass filter. I have my triaxial resultant. I have my displacement of my center Excel, displacement of my right Excel, the relative displacement between the two, and then my translation and rotation. I'm going to hit add all. Now all of them will be plotted. It's not very useful if you don't have a title for these graphs. So I will click here and copy attributes to all, and that way you'll be able to see what channels are each. So here is my channel averaging. Here is my bandpass filter for my input channel 1. Here's my triaxial resultant. Here's the displacement of my center Excel. Here's the displacement of my red Excel. Here's a relative displacement between the two. And then here is the translation and rotation. And if I want to view it in the frequency domain, I'll go to my frequency domain page. I will add a new graph, and I can add signals. I will select, go down here, selected, multiple graphs. Okay. And now I'll display all my data in the frequency domain, and I want to be able to apply these attributes to all of my graphs. So now I'll be able to see all the measurements here. So here's all of the different map channels in the frequency domain. So again, map channels are very powerful, and you're able to do a lot of things. Thank you for joining today. Again, my name is Holden Gibler, applications engineer for data physics. My contact info is down at the bottom if you have any questions. This will also be posted to our YouTube channel, our data physics YouTube channel, and you also can find that from our website as well. and I hope you all have a great rest of your day. Thank you.